Hey, so this is a video for 13.3 through 13.4. It's our April 6th through April 10th worksheet. And here we're going to look at specifically questions 11 through 16, which are right here. The goal here is to actually find the angle. In 13.1, we did problems where we had the angle, but we were looking for another side to the right triangle. And we used sine, cosine, and tangent to do that. Here, we're actually going to figure out how to figure out the angle that exists in a right triangle, given at least two sides of the triangle. So let's jump over to sort of a little note page. And so what we have to understand is that previously, if we had a problem that is a theta, okay, and this side was, say, 3 and this side was 4. We can always say that the tangent of our theta was equal to the opposite, which would be 3, over the adjacent 4. But this presented a problem. While I know the tangent is 3 over 4, I don't actually know what theta is. That right there is an unknown angle. So we wanted to find a way to calculate that. The truth is, the way that you would do this is you would take an angle, measure the tangent, and build a table of values. And this is done for centuries. We okay, well, let's go over 3, let's go over 4, up 3, let's get our protractor out and measure the angle. Well, you can only be so accurate when you do that. And so you would do this over and over and over again. And man, you gotta realize this was really time consuming. We had a lot of space to write all of this down. We now have calculators can do a lot of this for us. And so the question is, how do we get a theta alone? The way that we're going to get a theta alone is by using what's called its inverse, or sometimes what we call an arc. So there's two terms for it. There's an arc, and that's something you'll see listed in pre-calculus, but you'll use that same language. On a calculator, it usually shows up as tangent inverse, or tan inverse. That -1 exponent tells me that I'm going to undo or reverse the tangent. And so what we're going to do now, get rid of that. So what we're going to do now is we're going to apply this rule. Okay? And so if we have the tangent of theta equals 3 over 4, we're going to take the tangent inverse of both sides. Well, we have to understand that the inverse function will always undo the original function. This is something we learned about back in semester 1. Inverse operations cancel each other. Think of addition and subtraction. Well, tangent and tangent inverse are opposites. They will cancel one another, and the only thing left over here on the left side of the equal sign is theta. So that means that theta will equal the tangent inverse of 3/4. Now, tangent inverse 3/4, that's what used to have to be memorized or written on a big table full of hundreds of values. Anymore, we're going to use our calculator to do that. Now, I'm going to show you how to use the Desmos calculator because that's one that I think everybody will have at home. Biggest thing is to make sure your mode is correct. So first thing I'm going to do is come to my graph settings, and I am going to change the mode from radians to degrees. Definitely want to live in degrees. Truth is, there is a scientific calculator on Desmos, but I just always default to the graphing one. And what I need to do now is I need to type in tan inverse. It might let you type TAN raised to the -1, but I'm just going to come over here, pull up my keyboard, and functions. And under functions, you'll see all the inverses: sine inverse, cosine inverse, tangent inverse. So I'm going to pick tan inverse and do 3 divided by 4. And my angle in this problem is 36.9 degrees. Come back over and say theta must be 36.9 degrees. And so with that information there, I'm able to do a lot of really good work. So Let's pause for just a second. Okay, so one of the first things that we have to do when we're actually doing this, though, in these problems, is determine how do I know whether I'm using the sine, the cosine, or the tangent? Well, it really depends on which sides of the triangles you have. So from this angle's perspective right here, whoops, not what I meant. Let me go back there. I meant to go to draw. There we go. From this angle's perspective right here, okay, we don't have the opposite side. We have the adjacent side and we have the hypotenuse. That makes this a really good candidate for cosine. Now what you have to do is you have to set up your cosine of your unknown angle and say, what does it equal? Then once that's done, we can take the cosine inverse of your fraction and it should give you the angle. If you're getting angles bigger than 90 degrees, you're wrong. If you're getting negatives, you're wrong. I'm trying to think if there's anything else you should know. It's going to come out as a number between 0 and 90 because it's in a right triangle. It should. If you come down to the next problem set, like look right here at 13, we have the opposite now, and we have the hypotenuse. When you have the opposite side and the hypotenuse, it's a good candidate for sine of theta. Again, set it up and solve using the inverse function. And then here on 15, we have, or let's look at 16, you have the opposite, and you have, sorry about that, kids, and you have the adjacent side. So that would be a good candidate for tangent. Again, the trig ratio you start with is the inverse that you're going to use. So on a question like number 13, we said it was opposite over hypotenuse. The opposite is 11, the hypotenuse is 34. Well, opposite hypotenuse are a sine. So when I go to sine, when I go to do the trig function, I would choose the sine inverse, and I believe it was 11 over 34, 18.9 degrees. And so coming back to here, number 13 will be my 18.9. Hopefully that'll help you finding the angles. It's just using the inverse function, but make sure you set up the correct one. Again, based on what you're given. If you have the opposite and adjacent, it's tangent. If you have the adjacent hypotenuse, it's cosine. You just need to pick the correct one. Hopefully you spent time in the previous assignments learning how to build those fractions. All right, good luck, and we'll see you at the conferences.